In this video, we'll be talking about quadratic inequality. So let's get started. Let's first start with the part where we have quadratic. So what's an example of a quadratic expression? Here's an example: x squared minus 7x plus 6 less than 0. So this is an example of a quadratic inequality. But why do we call it quadratic inequality? This aspect is what makes it quadratic. So this is a quadratic expression and it has an inequality sign, and that's why we have a quadratic inequality. So how do you go about solving this kind of problem? You solve it by attempting to solve it first as a quadratic equation. And after solving it as a quadratic equation, then you try to figure out the inequality side of it. So that's the approach I'm going to use in solving quadratic inequality. So I'm going to solve this, then I'm going to solve a couple more problems, then wrap this up. So let's solve this. To solve this, we assume first that we are dealing with a quadratic you assume this to be a quadratic equation. So let's just take away the inequality sign. Just equate this to 0. Now let's solve this. Now to solve this, you use any of the method for solving quadratic equation. You could use factorization method or complete square method or the formula method. So I'm going to solve this using factorization method. So to solve this using factorization method, I'm going to look for two numbers. Let's say those numbers are m and n. And those numbers, when I add them up, when I multiply them, I'm going to get 6. I'm going to get the product of this coefficient of x squared times 6, so that will give 6. Then when I add up those numbers, I'm supposed to get the coefficient of x, which is minus 7. So when you think about it, you'll notice that those two numbers are minus 6. Now, what that implies is you're going to take minus 7x and replace that with minus x minus 6x. So which means you're going to have x squared minus x minus 6x. So you just take this one, add x to it. Then this minus 6, you add x to it. Then plus 6 equals 0. Now you solve for x. You solve for x, which is this. You factorize. You take out this x, one of the x. Then you have x minus 1. Then you take out minus 6. Minus 6 is common, so you'll be left with x minus 1 equals 0. So now you factorize further. You take out this common term, and that means you'll be left with minus 6 equals 0. Now you solve for x. So if this is equal to 0, that means x minus 1 is equal to 0, which means x equals 1, or x minus 6 equals 0, which means x equals 6. Now x is 1 or 6. So the next thing I want to do is to solve the inequality part. So this is what you need to take note of. After solving it as a quadratic equation, to get the exact answer, you need to note the following. These are the possible answers. It is either x is greater than 1 and x is greater than 6. There are 4 possible answers here that you could get, but one of them will be the answer. So I'm going to show you how you know the right answer. So it's either you have, this is a possible answer, x greater than 1 and x greater than 6. So you just take this 1 and 6. Another possible answer is that x is greater than 1, but x is less than 6. So you just flip this to be less than. The third possible answer is that x is less than 1, right? While x is for the other case, x is greater than 6. The fourth scenario is when x is less than 1, while x is less than 6. So these are the 2 possible scenarios. So how do you figure out which of these is the correct answer? So you figure that out by testing it. So you ask yourself, if this first answer is true, how can we test it? How can we be sure? So it's very straightforward. Just look at what this statement means. If x is greater than 1, it means x could be 2, 3, 4, and so on. And if x is greater than 6, it means x could also be something like 7, 8, 9, and so on. So you want to test for this scenario. You want to check if x is greater than 1. Can we say that if you substitute x as 2 in this inequality, will this statement be true, right? So let's test it out. So you substitute x as 2 in this equation. So you take this x squared minus 7x plus 6. I say it's less than 0. Now substitute x as 2 to test if this first possible answer is correct. So if you substitute 2 here, you're going to get 4 minus 14 plus 6. And that will give you if you simplify, that will give minus 4. So is minus 4 less than 0? So can we say minus 4 is less than 0? The answer is true. Yeah, we can say that. So which means x greater than 1 is correct, right? Because if you try something that is greater than 1, it makes sense. So let's see, can we say x is greater than 6? So let's try that. So let's try something greater than 6. So let's try something like 7. Or you could try 10 so that it'd be easy to compute. So if you try 10 here, you're going to get 100. That's 10 squared. That's 100 minus 70 plus 6. So if you simplify this, you're going to get 100, right? Minus 70, that's minus 30. That's 30 rather, not minus 30. So 30 plus 6, that's 36. So can we say 36 is less than 0? And the answer is no. 36 is not less than 0. So what does this mean? It means that x cannot be greater than 6. So if x cannot be greater than 6, it means this part is correct, right? But this part is not correct. This greater. So x must be less than 6. So you don't need to try the whole option. So since we've tried that this is correct and this is wrong, so it means it is the opposite that will be correct for 6. That means x must be less than 6. If x is not greater than 6, then it must be less than 6. So you just combine, you just look for the one that has these two. So if you check closely, x greater than 1 is here, x less than 6 is here. So this becomes the right option. So we can simply say that x is greater than 1 and x is less than 6. A simpler way to represent this is to look at it on a number line. So this is 1 and this is 6, right? Now, if you put this on a number line, it means x is greater than 1. It means you are going in this direction. X is less than 6. It means you are going in this direction. So it means x is between 1 and 6. And one way to write it is to just say x is between 1. X is between 1 and 6. So this is how you represent it. So it's greater than 1 but less than 6. So that is how you solve for quadratic inequality. So let's take a look at some examples from past questions. We're going to take some questions from UTME past question, and this time around we are going to take a look at question number 14 from the year 2016. So the question says we should solve the inequality x plus 4, brackets open and close, then x plus 1, brackets open and close, less than or equal to 0. So in this case, we are expected to look for the value of x. So let's take a look at how to go about solving this. Since this has been factorized already for us, so the next phase is just to look for the value of x, make with the assumption that we are dealing with an inequal we are dealing with quadratic equation. So just assume that this is quadratic equation, that is, equate this to 0, then try to solve for x. So in this case, x will be x plus 4 equals 0, then it means x is equal to minus 4. Then x plus 1 equals 0, which means x equals minus 1. So these are the two possible values for x. But now to get the exact answer, you have to test it. So now one easy way to look at it is just draw a number line. This is minus 1. This is minus 4. And this is minus 1. So you want to know whether x is to the left of this minus 4 or to the right. And you also want to check if x is towards the right. If it's towards the right, greater than. If it's towards the left, less than. So how do you check? So to test whether x is greater than minus 4, you try a number that is greater than minus 4, but not up to minus 1. So something that is greater than minus 4, but not up to minus 1 is minus 2, right? So you want to try minus 2 and see if that is the case. So you want to try, if I make x to be minus 2, will this statement make sense? So you try it out. So just say minus 2 plus 4, then minus 2 plus 1. So let's check this out. So this will give us 2, then times minus 1, and that will give minus 2. So can we say minus 2 is less than, because the question is whatever you get on the left must be less than or equal to 0. So can we say minus 2 is less than or equal to 0? Yes, we can say that. And because we can say that, it means it is reasonable to say that x is greater than minus 4. But then we want to test the other case, which is, can we say that x is greater than minus 1 or less than minus 1? Because it could be greater than minus 1 or it could be less than minus 1. So let's test it out. If you want to test if it's greater, you try something above minus 1, which is 0, because 0 is greater than minus 1. So let's try 0. If you insert 0 on the left side of the inequality, you have 0 plus 4, then you have 0 plus 1, right? Now, the next thing is you want to multiply. That's 4 times 1, right? And that will give us 4. So can we say that 4 is less than or equal to 0? No, we can't say that. This is wrong. 4 is not less than or equal to 0. 4 is actually greater. So which means it is not reasonable to say that x cannot, it's not reasonable to say that x is greater than minus 1. In fact, x cannot be greater than minus 1. Otherwise, this equation will not be incorrect. So in this case, x cannot be greater than minus 1. Anything greater than minus 1 will give you an invalid inequality. So which rules out the option of saying x is greater than minus 1. If you rule out greater than, then the alternative is less than. You don't have to test for it. It means less than is actually, it will be the answer. So this implies that x is between minus 4 and minus 1. So x is within this range. So one way to express it is say x greater than or equal to. Why you have to add equal to? Because the original expression has equal to. X greater than or equal to minus 4, and x is less than or equal to minus 1. And a compact way to represent this is to flip this one around. If you flip it around, it becomes minus 4 less than or equal to x, then you just combine it with this one, which is less than or equal to minus 1. So this is the answer. So let's see which option is the right option here. So the correct option here is option C, that is x is between minus 4 and the correct option here is C, but this time around with the equality sign, right? With the equality sign for both. Okay, so let's take a look at another example. So let's take a look at question number 18 for year 2013. So the question goes as follows. We should solve for the value of x where you have the absolute value of x minus 2 less than 3. So the question is solve for x where the absolute value of x minus 2 is less than 3. So let's solve for x. Okay, so what is the meaning of absolute? The absolute of a value of a number. So if I say this sign means absolute, right? So absolute means the positive value. So if I have something like absolute value of 2, the answer is 2. If I have absolute value of -2, the answer is 2 because absolute says knock off the negative value or just ensure it is positive. Get me the positive value of whatever is inside. So that is what this absolute value means. So how do you deal with this when it comes to inequality? Since you have an absolute value, it means whatever you have here is positive. Note that in inequality, if you multiply a value by a negative number, the sign changes. So, but if this absolute value is there, it implies that whatever we have here is going to be positive. And if you say it's going to be positive, that means whatever comes out of here is going to be positive. And if you say it is less than 3, it means whatever you have here is either 0 or 1 or 2, right? So, but then, how do you solve this case? One way to just go about, there are several approaches, but one way to solve it consistently is just take the square of both sides. Since we know this will be positive, then you can easily take the square. But if it is not, if you are not sure this part will be positive, you can multiply. You can't be sure if the sign will change or not. But in this case, we are sure that this part will be positive, and we're also sure that 3 is also positive. So for that reason, you can simply square this part. Whenever you square a value, you can remove squaring an absolute sign takes away that absolute value. In other words, if I square something like this, it means I can safely knock off the absolute value because the square of this thing will make it positive. So which means there is no point having the absolute value. So if you square both sides, so you square both sides to take away the absolute sign, right? Without taking away the absolute sign, you'll be having issues simplifying and all of that. So you can also square this, which gives you 9. And note that the reason why we are squaring this because we have absolute sign. If there is no absolute sign, you can't just square an inequality without considering the sign. Okay, so let's simplify this further. So this makes this x squared minus, if you expand this, minus 4x then plus 4 less than 9. So the next thing you want to do is to take this 9 to this side. That's x squared minus 4x plus 4 minus 9 less than 0. So let's simplify. This gives 4x minus 5 less than 0. So now we want to solve this with the assumption that we are dealing with a quadratic equation. So let's remove the inequality sign for now. So if we do that, that will give us, if we do that, that will give us the following: 0. We equate this to 0, then we solve. So what are the two, let's use factorization method. What are the two numbers you multiply to get minus 5? And when you add them up, you get minus 4. So if you think about it carefully, you realize that those numbers are minus 5 times 1, which will give you minus 5, and minus 5 plus 1 will give you minus 4. So it means you just take this x squared minus 5x then plus x minus 5 equals 0. So you factorize. If you take out x, you're going to get x here. Then you have x minus 5. Then if you do the same thing here, you're going to get, since it appears nothing is common, you just bring out 1. Then you'll be left with x minus 5 equals 0. Then if you factorize further, that will give you x minus 5. Then x plus 1 equals 0. So the next thing I want to do is to find the value of x. So in this case, x minus 5 equals 0. Then that means x equals 5, right? Then for the other case, if x plus 1 is equal to 0, it means x equals minus 1. So x is either 5 or minus 1. So the next thing is to figure out the real answer. So to figure out the real answer, you have your number line. Minus 1 is a smaller number, so it will be on the left side. Minus 1 here. Then you just indicate this. Then 5 is the bigger value, so it will be on the right hand side. So this is 5. Then you have your indicator. So the next thing is you want to check, can we say x is less than minus 1 or greater than minus 1? So you want to test. So how do you test? So you say if x is greater than -1, and we plug that into the original question. So you plug that into this, right? Can we say that this is the original question, right? If you take x to be -1 and you insert that here, will it make this statement true? So let's check. So let's check. Let's first try a case where x is greater than -1. That is this direction. Now, what are the values that are greater than -1? 0 is part of it because 0 is within this range, right? So let's plug in 0 here. Why you should try simpler values so that your computation will be much faster. So you insert 0 here. That gives you the absolute value of -2. So that what is the absolute value of -2? That's 2. So can we say 2 is less than 3? Can we say that? Yes, we can say that because 2 is actually less than 3. So it means this zone is correct. We can actually say x is greater than -1. So the next thing we want to try is, can we say x is greater than 5 or less than 5? You can try any of them. You can try greater than 5. So let's see. So let's try greater than 5. So in this case, what we want to do is to insert any value greater than 5. So let's try a value like 6. So 6 minus 3 minus 2 rather. The absolute value of that will give you 4, right? So the absolute value of 4 will give you 4. So can we say 4 is less than 3? The answer is no. 4 can't be less. 4 is not less than 3. So for that reason, x can't be greater than 5 because it will give you an invalid inequality. So it means the alternative is that x is less than 5, not greater than 5. So since x is within this range, the answer is very straightforward. You just say x is greater than -1 and is less than 5. So that can be expressed as -1 less than x and x is less than 5. So that becomes the answer. So let's see which of the options is correct here. So that gives the right option is option B. Okay, so let's solve one more question. So we're going to solve a question from question number 15 from 2018 model 1. Okay, so let's take a look at this question. The question states that 21 less than x squared minus 4x. And the question says we should find the value of x. We should solve the inequality, right? So how do we go about it? So let's take a look at it. So we're going to use the same approach that we have always used, right? So what one strategy we want to use is let's take everything to the other side, or just make it an equality. Just turn it into a quadratic equation. So to turn it into that, just make this sign equal to and just solve it as if you are dealing with quadratic equation. So that gives you 0 equals x squared minus 4x minus then minus 21, right? So you can say x squared minus 4x minus 21 equals 0. So let's solve for x. So solve for x, you simply ask yourself, what are the two numbers? I'm using factorization method. You can use any method you want to use. So what are the two numbers I need to multiply to get minus 21? Then when I add them up, I'm going to get minus 4. So if you think about it carefully, you'll see that those two numbers are minus 7 times minus 3. That will give you minus 21. Then that will give you plus 21. But to get minus 21, you have to do the following. So in this case, you have to do the following. That's minus 7 times 3. You change one of these to be positive, and that will give you minus 21. So if you add them up, minus 7 plus 3, that will give you minus 4. So the two numbers we're interested in, they are minus 7 and plus 3. So what you simply do here, just take x squared, then you have minus 7x, then plus 3x minus 21 equals 0. So you factorize. Take out the x, one of the x. then you have x minus 7, then you check what's common, that's 3. So if you take out 3, that's x minus 7 remaining. So you want to bring out the x minus 7, then you'll be left with x plus 3 equals to 0. So the next phase is to solve for x. So you just say if x minus 7 equals 0, then x will be 7. Or if x plus 3 equals 0, then x will be equal to minus 3. So now that you've got the value of x, the next thing you want to do is to check, you want to get the exact answer, right? So to do that, you want to have your number line. So your number line will indicate where you have the smaller number is minus 3. So minus 3 will be on the left. The bigger number is 7. So you have 7 on the right. Now, the next is to check. So you have your indicator here and you have your indicator here. So you want to check, is x less than minus 3 or is it greater than minus 3? Or is x greater than 7 or less than 7? So we're going to test. So let's test a case where, try to test an easier case. So an easier case is where your computation will be much easier. And one of those easier cases are cases where you have x as 0, right? Because if I plug x as 0, I can easily solve for that. So where can we find 0 basically? We can find 0 if you assume that x is greater than minus 3, because 0 is between minus 3 and 7. So let's try that case. So let's assume x is greater than minus 3. And let's see whether this inequality will make sense. So if you assume x to be minus 3, and I'm sorry, x is greater than minus 3, which means x to be 0. Let's choose a case where we have 0. It means we're going to plug 0 on the left side here. On the right side here, that will give us 0 squared minus 4 times 0, right? And that will give you 0. Now, can we say 21 is less than 0? Can we say this 21 that's on the left side is less than 0? No, we can't say that. This doesn't make sense. 21 can't be less than 0. So for that reason, x can't be on this zone, right? X must be on this zone. If greater than fails, it means the reasonable thing to the alternative is correct. So x is on this zone. X is less than minus 3. So that's basically what it means. It can't be greater than minus 3 because we've tested a case where we have x greater than minus 3. So the next thing you want to test is, can we say x is greater than 7? So let's try a case where x is greater than 7, and one of those cases happens to be 8. So because 8 is greater than 7, so let's try that. So if you plug in 8 here, 21 less than, so let's plug x as 8 here. So that's 8 squared minus 4 times 8. So 21, let's say this is 64 minus 32. So can we say 21 is less than, it is less than this 32, right? It's less than 32. And if you think about it, that's true, because 31 is less than 21 is less than 32. And that makes this statement true. And because this is true, it means we can confidently say that x is greater than 7. So what then will become our answer? We can simply say that x is less than minus 3 and x is greater than 7. To make everything compact, you can simply flip this side. If you flip this first one, that will give you minus 3, you just reverse this, minus 3 greater than x, and x less than 7. So this is a more compact way to represent the two inequalities. So let's check what the right option is. If you check closely, you'll see that option B is the right answer. So this brings us to the end of quadratic inequality.